Hey guys, my name is Talia. I'm a staff member at Discovery and I'm going to help you do your homework today. Alright guys, today we're going to do another question related to the normal curve and normal distribution. There's a lot of these out there, but I like this one because in one 3-part question, you have to do a lot of different things, and so I really like it for that reason. But essentially this question is based on blood pressure data. We have a bunch of data about different people's blood pressure recorded. And we know that the average blood pressure, this is given to us in the question, right? The average blood pressure is 140. I think the units is like milligrams, HG, or unimportant. Units are unimportant. But anyway, it's 140 with a standard deviation of 20. And when you put your data on a histogram, it says, oh, well, it pretty much looks like a normal curve, right? It's close enough. And for that reason, we are comfortable using the normal approximation, assuming this data has a normal distribution, to solve these probability questions that are given to us. And so knowing those 3 things, let's say knowing these 3 things, we can then use what we know about normal distribution to estimate answers to these questions. And so let's look at the first one here. You want to find the percentage of people between 117 and 163 blood pressure, right? And so the way I always like to start out with these questions is by drawing pictures. I'm a big picture person, a big visual learner, and I think with these it's especially helpful because you'll make a lot less mistakes. So let's draw the normal curve based on the information in our problem and our given values, because it's going to help us visualize the area that we're finding, right? So this is a normal curve. The area under this whole thing is 1. This is all of our possibilities, and our total area of everything added up is 1. And then by implementing the information we have, we can visualize our subset of this area that is the same, that is our probability, basically. And so for the normal curve, it's always centered at the mean, right? So our average is 140 blood pressure. And let's put this, I like to say like an X scale, like the original scale, and then later we'll convert it to the Z scale. But basically, centered at 140, and then we want to visualize our area that's between 117 and 163, because if this whole area is 1, if we can find some subset of that area and find that, that's our probability, right? And so we want to find the percentage of people between 117 and 163. So 163 would be above the mean. Let's say here roughly, I don't really know, it doesn't matter. And then 117 would be below the mean here. And so we know that the percentage of people between 117 and 163 is this area in the middle here, this shaded in area, right? And so when we would approach these problems, a lot of times they're a little bit more simple, and it will just ask you something like, what's the probability that your blood pressure is less than 163, right? And then you just find the z-score for 163 and do p-norm for that z-score and then get that number, right? But in this case, it's a little more complicated than that because we're not going all the way to negative infinity, right? We're bounded between 2 different values. We have a lower bound at 117 and an upper bound at 163, and we're finding the area in between those 2. And so there's an extra step here, an extra thing we have to think about in order to get this specific area instead of just everything here, right? So if you think about it, if we want to find this area in between, if we did p-norm 163, that would be from here all the way to negative infinity. But like I said, we don't want to go all the way to negative infinity, right? We want it to be less than 163, yes, but also greater than 117. And so that means we don't want whatever is less than 117, right? We don't want the area that's less than 117 because that does not match our problem, right? And so if we can do p-norm for the z-score of 163 and get this whole area, the trick here is that you can find p-norm for 117 and subtract it, right? Because p-norm of 117 goes from 117 to negative infinity. It's everything that's less than 117. And that's not what we want, right? We want it to be greater than 117 and less than 163. And so we can actually find this whole thing and subtract this just to get our area in the middle, which is the answer to our question. And so that's the trick here, right? Subtraction of these 2 different percentage values to get what's in the middle. And so now to do that, just like normal, we find our z-scores for both of these values. When we do z-scores, that means we change the average to 0, we center it at 0, and then we use the standard deviation to find how many standard deviations these values are away from the mean, right? And so our formula for that is value minus average over SD. So for 163, we have 163 minus our average of 140 divided by 20, which is, I wrote this down, 1.15, right? So on our z-scores, our z-scale, 1.15 goes here. So this just means that 163 is 1.15 standard deviations above the mean. And then for 117, our z-score is our value, 117 minus 140 over 20, which is actually negative 1.15. Kind of funny, it's the same z-score, but in the other direction. So negative 1.15, right? And now that we find these z-scores, we can use Python or a normal table to find this area, right? Just like we said before, we want to do, I'm going to erase this if that's fine, now that we found it. So to find the area all the way to the left of 163, we do norm.cdf of its z-score 1.15, right? And this output will give us everything from here to negative infinity, but then we want to subtract this. So we subtract norm.cdf of negative 1.15, right? So that will give us just this area in the middle here like we want, and that ends up being 0.7498561, blah, blah, blah. Unimportant. It's multiple choice, and they rounded it to 75%, right? Because you just gotta move it anyway. So our answer is 75%, right? And so we know that 75% of all people, approximately, in our data, have blood pressure between 117 and 163. Using this normal approximation, we found this area in between our values. So yeah, that's the first part. There's two more that are kind of similar, so let's go through those. Now we're finding the percentage of people between 140 and 163. So we can do this with pretty much the same exact process, right? We already found our z-scores for everything. So let's do that. Let's mark it up again. 140 is our center, right? We know that 140 is our mean, and then 163 is a little higher than that. That's on our original scale, and our z-scale, 140 is 0, right? Because you know, I'll write it out, right? So you know that value minus average over SD, well, if our value is the same as the average, then that's just 0. And then 163 we already found is 1.15. And in this case, you can do the same thing. You can do norm.cdf of 1.15 because we're finding this area in between here, but then subtracting everything here, minus norm CDF of 0, and that will give us 0.3749. And then that will be approximately, I think they rounded up to 37.5% on Mastery Platform. But the thing about this also, and the reason I wanted to do this question is because you don't really have to do norm CDF of 0, right? Because one property of the normal curve is that the mean splits everything in half, right? So 50% of our data is higher than the mean, and 50% of it is lower than the mean. And so if we know that 140 is our mean, like this is kind of redundant because we just know it's 0.5. So you can just type 0.5 here, right? And that's kind of a little bit of a trick, right? If you really understand normal distribution, you can tell that anything between 140 and 163, well, it goes from 50% to whatever this percent is, right? And you can just subtract the 50%. That's less than the mean. And you'll get the same answer that way. So that's the second part, right? Our final question, this is more of our basic, like, over or under this value normal distribution question that you'll find, right? Like I said, these are a little bit a couple extra steps and a little bit more thinking because it's a between problem, but this is a basic like over 163 problem. So again, let's draw a normal curve and then shade in our area like we had before. This is kind of redundant at this point, but like I love pictures, so I'm gonna draw it every time because you should draw a picture every time. For every class, always, because pictures are great. 163, this is a mess. If you draw a picture, actually make sure it's better than mine. 163, right? And then we already know this, 1.15. And we're finding the area over 163. So that's this tail here. It's not gonna be a very high area. And this, there's a little bit of a trick of this one too, right? So norm.cdf, like we demonstrated over there, norm.cdf finds the area to the left of the value that you put in, right? So it's from your value all the way to negative infinity. But if we know that the entire area under the curve is 100%, then if we want to find instead what's to the right, we know we have norm.cdf is this, the whole thing is 1, so we can do 1 minus norm.cdf of 1.15, and that will actually give us our area to the right, which is what we want, and that's the probability or the percent of people that have blood pressure greater than 163. And so if you plug that into Python, that answer is 0.12507, blah, 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 blah. Essentially 12.5% is our estimation here. So hopefully that makes sense, the whole 1 minus thing. That will essentially happen every single time you find a problem that asks you to find greater than or over. You're always going to do 1 minus because by default norm.cdf goes to the left. So yeah, those are the 3 separate parts of this question. These 2 are pretty similar, but this one, the trick is just that it involves the mean. And yeah, I got a few questions about this every semester in office hours, so hopefully this kind of clears it up and explains the extra little bit of thinking that you have to do with this question.